Welcome back to Kamal Kunj Home Academy, Encounter with Mathematics. In this session, we will discuss about a theorem according to which tangent to a circle is perpendicular to the radius of the circle at the point of contact. What is given here? A circle with center O and line AB is tangent to it. Line AB is tangent to it at P. Then let's prove that OP will be perpendicular to AB. What is given here? It is given line AB is tangent to the circle at the point of contact P. OP is the radius of the circle. Now, what is to be proved? To prove OP is perpendicular to AB. Now proof. There exists a point Q on the tangent line AB there exists a point Q on AB such that P is not equal to Q. This implies that Q is in the exterior of the circle. Q lies in the exterior of the circle. Let OQ intersects the circle at R. Let us suppose that OQ intersects the circle at R. This implies that OR is less than OQ. This implies that OR is equal to OP. OP is less than OQ. It means OP is shorter than OQ. It means line segment OP is shorter than any line segment joining O to any point on the line AB. Line AB. Since Q is any point other than P, and hence OP is shorter than any line segment joining O and any point on this line AB. This implies that OP is the shortest line segment. This implies that OP is perpendicular to AB because shortest line segment is the perpendicular line segment. Shortest line segment is the perpendicular line segment. Hence, OP is perpendicular to AB. Now, this can be proved even by another method. Alternate method. There are two possibilities. Either OP will not be perpendicular to AB, or second, OP will be perpendicular to AB. So there are two possibilities. There are two possibilities. Either OP is not perpendicular to AB, or number 2, OP is perpendicular to AB. Now case 1, when OP is not perpendicular to AB, when OP is not perpendicular to AB, then there exists a point Q such that OQ is perpendicular to AB. Since OQ is perpendicular to AB, this implies that OQ is less than OP, because perpendicular line segment is the shortest segment. Since OQ is perpendicular to AB, it means OQ is less than OP. This implies that OQ is less than radius of the circle. This implies that point Q is in the interior of the circle, is in the interior of the circle. Since OQ is less than radius of the circle, it means point Q is in the interior of the circle. It means, this implies that line AB intersects the circle at 2 points. Sets the circle at 2 points. Now, since line AB intersects the circle at 2 points, it means AB is not the tangent to the circle. This means, this implies that line AB is not tangent to the circle. But what is given here? Line AB is tangent to the circle. So this contradicts the given statement. This contradicts the given statement that this contradicts the given statement that AB is tangent to the circle. This implies that OP is not perpendicular to AB is false. When we assume that OB is not perpendicular to AB, we come at a wrong statement. Therefore, OP is perpendicular to AB. Now we will stop here and continue further in the next session. Till then, goodbye and thanks for watching.